All right, Unit 3, Lesson 9, you have made it to the final lesson of the course. Congrats to you. We have two objectives. We are going to write quadratic functions in that form that we graphed them in last lesson. And then we are going to find the vertex of a parabola. I'm actually going to do this backwards. I'm going to start with the the second objective, because it's the quicker one. And I'm going to learn from my mistake of 2 videos ago. I'm not going to try to derive this formula because it'll be far too complicated, more than you want to see. I'm just going to tell you there's a really easy way. Remember that the standard form of a quadratic equation is f of x equals ax squared plus bx plus c. Now, we're going to be taking functions in this format and rewriting them in this format later on in this section, but for now this is very convenient because we can figure out the vertex quickly from this. There's a formula for the vertex, and it is the x value of the vertex is equal to negative b over 2a. So all we do is we take the negative of this number and then divide it by 2 times this number, and that gives us the x value of our vertex. And then to find the y value, well, we just take that number and plug it in. So we take the function value of negative b over 2a. Let's look at an example of this. So let's say you have, let's do it in green. Why not? Green's a happy color. F of x is equal to 2x squared minus 8x plus 11. I don't know what happened to my x here, but got chopped off. 2x squared minus 8x plus 11, and you want to know where is the vertex. Well, the vertex is at, let's find its x value first. The x value is negative b over 2a, which is negative 8, because negative 8 is the b, over 2 times 2. So the x value of the vertex is 8 over 4, which is just 2. Well, that's nice. It worked out to be a whole number. Now that's half of it. We still have to figure out what the y value is. Well, so just to find the y value, all we have to do is plug that in to the function. So let's come back to the function and let's say, well, what is the function value of 2? In other words, what is y when x equals 2? So that's 2 times 2 squared minus 8 times 2 plus 11. I'm just replacing x with 2. That's all I'm doing. So this is 2 squared is 4 times 2 is 8 minus 8 times 2 is 16 plus 11. So 8 minus 16 is negative 8 plus 11 is positive 3. So this tells me my vertex is located at 2, 3. So that's pretty quick. That's a very convenient formula. So let me write it again one more time just to emphasize. The formula for the vertex is negative b over 2a. That's the x value. And then the y value is f of negative b over 2a, which is just another way of saying take the x value you get and plug it back into the function to figure out what y equals. Not too bad. Pretty straightforward. I like to say straightforward a lot, I've noticed. I'm learning this about myself. Let's do one more example of that, and then we'll move on to the harder one. So let's say you have, we'll make you think a little bit this time. F of x is equal to x squared plus 3x minus, oh, don't make it something too easy, minus 5. Okay, well, if I go negative b over 2a here, if I do negative b over 2a, I'm going to get negative 3 over 2 times 1, a is just 1 here, or negative 3 halves. But that's a fraction! Yes, your answer could theoretically be a fraction. You can have a vertex anywhere. It doesn't have to fall on a whole number. Now, of course, you like this less because now that means more work for you in trying to figure out the y value. course, you're just going to plug it into your calculator anyway, so what do you care, right? So now we need to figure out what is f of negative 3 halves. Well, that is negative 3 halves squared, that's a squared, plus 3 times negative 3 halves minus 5. We're going to have to do some fraction math here. Negative 3 halves squared is just 9/4. And then you see 3 times negative 3 halves, well, that's minus 9 halves. Remember, I'm thinking of this as 3 over 1. I'm just multiplying straight across. Minus 5. Well, if I'm going to combine all of these, I need a common denominator. Clearly, my common denominator is going to have to be 4. Again, think of this whole number as 5 over 1. So this is going to be 9/4 minus, let me use a different color here to make this stand out. What did I do here? I have to multiply by 2 on top and bottom to make that 4. And then on here, on this last one, I'm going to have to multiply by 4 on top and bottom. So this becomes 18/4, and this becomes 20/4. And of course, you can reduce all of those and see that they're still equal to the right number. So now it's just a matter of doing the math there. 9 minus 18 is negative 9. Minus 20 is negative 29/4. So, for this problem, my vertex is at negative 3 halves, negative 29/4. And those numbers aren't as bad as they look like. That's negative 1.5 and negative 7.25. It's really not that awful. It's just fractions make us all a little bit queasy, right? Okay. But that's pretty straightforward. You'll have, there I go saying straightforward again. Darn it, I got to come up with a different word. You'll have several problems there to figure out what the vertex is. Okay, so now let's go on to writing quadratic functions in this form. F of x equals a times x minus h squared plus k. And for this, I'm going to pull an example off of the assignment. So let me pull that up real quick. Yes, you're looking at the assignment here. Okay, here's a good one. Find the vertex and blah 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 blah. Find any intercepts. Sketch the graph. Nope, that's too easy. You can figure that out. By the way, I'm glad I pulled this up. Notice it says find any intercepts. Well, we did that a long time ago. To find intercepts, you just would need to set the whole thing equal to 0 and factor, right? Or use the quadratic formula, or complete the square. There's 3 different methods there. But if it factors, go ahead and factor. That'll give you the intercepts. That's how we figure those out. We set f of x equal to 0. Okay, but that's not what I'm looking for. I am looking for, you can do that. That one's easy, like what we did last time. I am looking for this problem, I think. Darn it, that one's no, that's good. We'll look at this one. This one's pretty easy to find the intercepts, but let's look at these numbers because this will be a good example of how we can write one in this different format. So we've got f of x equals x squared minus 8x plus 7. Let's bring that into OneNote. And we're going to do it in red because red makes everyone happy. And by happy, I mean mad. Why is my pen not? There we go. F of x equals x squared minus 8x plus 7. Now this factors really easily if I was just asking you to factor it. But you're being asked to graph it and find a whole lot of information out about it. Let's go back to the homework so you're reminded. Sketch the graph of the function. Well, in order to sketch the graph, you're going to have to know some things because you got to be able to find where the vertex is, which in this case is pretty simple because you're going to use negative b over 2a and you're going to figure it out really quickly. And then you've got to be able to find another point to graph it. So not too bad there, but let's use this as an example of how we can work this out. We could figure out the vertex a different way and all of the other information we know about it by actually completing the square on this. What I'm going to do is I'm going to come in here and put some artificial parentheses. Let me use a different color to show this. I'm going to think about the 2 terms that have the variable on them, and I am going to complete the square within those parentheses. Now, in order to keep this all equal, I'm going to have to balance that out by doing something else, and we'll look at that in a second. But how would I complete the square? Right? If you go back a couple of videos, remember what I would do is I would take half of this number, square it, and add it. Well, what is half of negative 8? Half of negative 8 is negative 4, and if I take negative 4 squared, I get 16. So what I'm going to do is I'm going to add 16 inside of those parentheses. So let me come back and do that. So I have f of x is equal to x squared minus 8x minus 16. Now I'm going to keep this in parentheses because I want to group that. But now I've got this plus 7 out here, and I need to do something else because I can't just randomly, why did I say minus 16? It's plus 16. Whew, almost made a bad mistake there. I can't just randomly add 16 to the problem. It changes the value. I've completely changed the problem. Unless I also subtract 16. Pretty clever, right? Think about it. If I add 16 and subtract 16, what have I done? I've really done nothing. I have added 0. Plus 16 minus 16. So by doing that, if I can add 16 as long as I subtract 16 also. It keeps it equal to what it was. But the benefit of doing this is now I have a perfect square trinomial here in these first 3 terms where I've written the parentheses. So hopefully you notice that this is x minus 4 times x minus 4. You can do the math there to check that. And then let's go ahead and combine these last two. We've got plus 7 minus 16. Well, that's a minus 9. So x minus 4 times x minus 4, well, we know that is x minus 4 squared minus 9. And look what we have done. We have just rewritten this function, this original function up here. We have rewritten it in the format we were looking for. This is now in the form, let me write it in a different color so it stands out. This is now in the format f of x equals a times x minus h squared plus k. That's what we were wanting to do. We've accomplished that. So by looking at this, I can see, well, where's my vertex? My vertex is going to be at, let me write it, I'll keep it in green. My vertex is going to be at positive 4, negative 9. And that's just from looking at h and k, I can tell that. Now remember, you could have used negative b over 2a to figure out your vertex also. You could have said, well, negative 8, that's positive 8, over 2 times 1 is 2, so 8 over 2 is 4. In this case, negative b over 2a works out to be 4. And then if you plug 4 back into the equation, you will see that you end up with negative 9. So this would have also given you a vertex of 4, negative 9. But I wanted you to see how you can use completing the square to take any function that's in standard form to this very helpful format. Now, that was an easy example because you probably could have graphed that without having to do this. But let me pull up the next one. See, it's either 7 or 8 is the one that's going to require a little bit more thought. Yeah, that one has some funky stuff going on. Let me see what 8 is. I think 8's. Now, 8 is already in this format, so this is basically exactly what you did on the last section. It's just that there's fractions involved, so don't worry about that too much. Let's look at 7, and we'll do this one. Negative 2x squared minus 6x, because this one is going to have a little bit more going on with it. Negative 2x squared minus 6x. Let's come back down here. Let's get some extra space. So we've got f of x is equal to negative 2x squared, and I can't remember if it was plus or minus. I'm sorry, I'm losing my brain. Minus 6x. So where's my one note? Minus 6x. Okay, so I want to use completing the square to rewrite this in our graphable format that tells us a whole lot of information. So let's do that. Well, first thing I would do, if I'm looking at this, is I need to factor out the common negative 2. Because if I don't, how am I going to complete the square? Because if you'll recall from completing the square, the first thing is you've got to have a equal to 1. Well, right now, a is not 1, a is negative 2. So I need to change that. So let's factor out a negative 2. So we've got f of x is equal to. Now keep in mind, if this is confusing, you're only going to have to do one of these on the homework. And you can always view an example or do a help me solve this. Pull out a negative 2, and that leaves me with x squared plus 3x. Alright, now we're going to complete the square. And yes, there's going to be some fractions involved, but it's okay. Everyone's going to survive. So remember, to complete the square at this point, I'm going to take half of my b term. Well, my b term is 3. So I'm going to take half of that. Well, unfortunately for everybody, half of that is, whoa, why am I still on, I don't want to be on highlighter anymore. Half of 3 is 3 halves. Let's just leave it as a fraction. Let's not turn it into 1.5. That'll make things worse. We're going to square that. Right? We take half of it, we square it. Well, if we square that, we get 9/4. So we're going to add 9/4 to this equation. So we have f of x is equal to negative 2 times x squared plus 3x plus 9/4. Now it's important that I add that 9/4 inside the parentheses, because now if you remember back to the last example, I cannot just randomly add some value to this problem. I've also got to subtract the exact same value in order to keep it equal to itself. But I didn't actually just add 9/4 there, because think about what's going on. I've got this, let me show it in a different color. I've got this negative 2 out here that's being multiplied times everything in these parentheses. So really what I did is I added negative 2, negative 2 times 9/4, which is equal to negative 18/4, and let's go ahead and reduce that to negative 9/2. So what I've really just done here is added or subtracted 9/2. I've added a negative 9/2. So if I wanted to cancel that out, what I have to do is the opposite, right? So I have to come up here to my equation and I have to add 9/2. Now I know that's going to probably confuse some people, because I didn't just, you say, well, how can you do this? You're adding and that, how do those cancel out? Because you've got to remember, this 9/4 that's in the parentheses in here is being multiplied by negative 2. And if you do the math on this, if you distribute out the negative 2, you'll see that again, I need a different, let me use something else. You'll see that this term and this term cancel each other out. So that's what I need to keep it equal. I need to add and subtract identical values. Okay, so let's get back to the problem. So at this point, you can get rid of these marks here. At this point, I've got a perfect square trinomial. It may not appear as one, but it is. I'm probably going to have to, well, I'll just go back up here with it. So what I have is, I'm going to come up here. F of x is equal to negative 2 times, well, what is my perfect square? My perfect square is actually x plus 3/2. Where did 3/2 come from? Remember, it's this number right here. It's half of that 3. Half of that b term is what I'm using. And that business is being squared. And again, do the math on it if you don't believe me. If you're wondering where did that come from, do x plus 3/2 times x plus 3/2, and you will see that you get x squared plus 3x plus 9/4. That's what you get. And then of course I've got a plus 9/2 on the end. So, looking at what we have here, we've now just done it. We've finished. We've got it in the format we wanted. We can tell where the vertex is because I can see that I've got an h and a k. My vertex is going to be at negative 3/2, 9/2. We can see that a equals negative 2, so that tells me that this opens down and is narrower than a regular parabola. So we know everything we would need to graph this. We know we can also, if you're wanting to find the intercepts, and go back and say this, if you're wanting to know what are the x-intercepts, remember you should come back to this original format, set it equal to 0, and solve for x. That's actually pretty quick to do. Factor out a negative 2x and you'll get there very quickly. Okay. I really think that's all you need. There's not very many. There's only 8 problems on the last assignment, and a lot of it is overlap. There's only a couple where you have to do this math to solve, and in fact you might be able to get around it if you're really clever. Okay, good luck. You've made it almost to the end. Stay on track, and email me with questions.